So in this question here, this setup, you can see there's two supports at X and Y, okay, so causing the reactions then, R1 and R2. There's a weight at C of 0.5 G, okay, which is 0.5 meters from A. It's always useful in these questions to put the whole length of the rod above, 1.6. So we know that if it's 1.6, you're going to have then 0.8 going to halfway, which will be the weight of the rod. Okay, and then we can split these up. I think it does say in the question that AC is 0.5 and then AX is 0.6, so that's going to be 0.1 and then you're left with 0.2 there. So you can see how all this is split up. So what we do again then, to get the reactions at X and Y, what we say, that forces up equals forces down. So we've got R1 plus R2 is equal to 0.5 G plus 4G. So R1 plus R2 is 4.5 G. Okay, so reactions going up will total the weights going down. So R1 plus R2, let's put that in terms of an actual value. So times it by 9.8, so you get 44.1 newtons. Okay, then to work out what the reactions are, we'll take moments then. It's important where you take moments. If we take moments about, say, X, okay, then we can eliminate that reaction then, because this will have zero moment basically if it's going through the point of moments. Okay, so if we look at the clockwise moments about X here, okay, well the 4G would be clockwise, wouldn't it? Because if that's like a century clock, this would be going clockwise, so it'd be 4G times the distance then, which is 0.2. The R2 will be going anti-clockwise about this point, anti-clockwise, and the 0.5 G will also be going anti-clockwise. If there's the century clock, that's going anti-clockwise, isn't it? So the only clockwise forces we've got is 4G. It's the 4G weight there, so you times that by the distance, so we've got that as the clockwise one. The anti-clockwise then would be then is 0.5 G times the 0.1, and then the R2 is also going anti-clockwise about X, so that would be R2 times that distance there from X, which would be 0.2, 0.4, 0.6. Okay? So from this then we can work out what R2 is. So 4 times 9.8 times 0.2 equals 0.5 times 9.8 times 0.1 plus R2 times 0.6. So if we do a bit of equation work there, we get R2 to be out 12.25 newtons, and all you've got to do then is sub it in then to equation 1 here to get your R1, sub into 1. So R1 then plus 12.25 will equal 44.1. So R1 then you just take it away and you've got the answer, 44.1, take away 12.25 and we get 31.85 newtons. Okay. Now part B, it goes on to say that we've got when an additional particle of mass m is attached to point C, the rod is on the point of turning about X, calculate the value of m. So if you think about it now, we've got this extra weight, as well as this 0.5 G here, we've also got an extra mass of m kilograms added on. So we'll have an extra weight of mg here, and it's going to tilt. When you add something extra here, it's going to tilt about X. Okay? It's literally on the point of tilting so that it will tilt at X and it'll start to flip. Okay? Because the mass that's been added here is quite heavy and it's about to tilt about X. Now what's good about that is, let's think about the reactions here. Because you're adding more mass here at C, because you're adding more mass, there's more weight here, then it's going to be more stress at X. The reaction is going to be higher. So this reaction at X will increase, it's going to go up. Okay, because there's just so much more weight here, there's so much pressure on the support at X, this is going to increase. But if it's going to tilt about X, think about what happens to the reaction at Y. If it's on the verge of tilting, then that support there won't, if you think about it, won't have any effect at all. In other words, R2 will actually become 0. Okay, That's what will happen, because as it's about to tilt, it won't have any effect. Here, that support won't have any effect at all on the rod, because it's about to tilt up. Okay, so as if it's not even touching it anymore. Okay, so what we say is, on point of tilting, about X, okay, we could say the reaction at Y will be 0. Okay, so that means this becomes 0. So now we can take moments about X again, right? But this now won't have any effect because there's no reaction there, it'll be 0. So we take moments about X, okay? Well, moments about X, we've got, of course, this one going clockwise, which is 4g times 0.2. Okay, so we've got that there, 4g times 0.2. Okay, that's the clockwise one. Of course, then this is the anti-clockwise one. So, but now remember, now we've added an additional m on here, mg. So that'll be then 0.5g plus mg times the distance of 0.1. Okay, and that's it. There's no other forces there. There's no other moments we take. Okay, because that as I said, that's disappeared. That's become 0 because it's tilting about X. That's gone. Take moments about X. Of course, the R1 doesn't have any effect. It's just these two forces. So we can work this out here. We'll have 4 times 9.8. .2, so that'll be 7.84. And then let's multiply this bracket out. So 0.5 times 9.8 times 0.1. So if I do that first, I get 0.49 plus then 9.8 times 0.1 is 0.98 m. Okay, so then take that over 7.84, take away 0.49, so get 7.35 equals 0.98 m. And you can get your m then. 7.35 divided by 0.98, you get your m to be 7.5 exactly kilograms.